Hello everyone, welcome to the coding school. Today we are looking at a interesting problem which is printing the top view of a binary tree. So let's look at the problem statement. The problem is saying you are given a pointer to a root of a binary tree and you just have to print the top view of a binary tree. What does it mean? It's simply saying that you had you have given a binary tree, and if you look at the binary tree from the top, which are the nodes that are visible from the top. For example, in this case, if we look at the top of this binary tree, then 1 will be visible, and then 2 will be visible, and 3 will not be visible because it is coming just below the 2. So it will be hidden by 2 actually, and 5 will be visible, and 6 will be visible, and 4 will not be visible because it is coming below to the 5. So the nodes which are visible are 1, 2, 5, 6. And also observe one thing over here, we are printing the top view in left to right manner. You can also see the actual input and output. From the output we can also figure it out that we are printing the top view in the left to right manner. So over here the left side, the leftmost node is 1, then the next node is 2, then the next node is 5, and then the next node is 6. So it is actually left to right manner. Now let's look at the uh, explanation that how can we solve this problem. So for that, let's suppose I'm having this binary tree. The root node is 1, and the other node are also displayed over here. So over here in this tree, if we look at from the top, so 1 will be visible, then 2 will be visible, and 3 will be visible, and 6 will be visible. Other nodes will not be visible because it is coming below some other node actually. So these nodes will not be visible. So how do we get these nodes which are visible? For this, I'm using a method like, uh, let's go with the BFS traversal of this binary tree. So what I'll do, I'll traverse I'll traverse the node level by level. So I'll first traverse this level and I'll explore all the nodes of this particular level. And let me define one more thing, that is horizontal distance. So what is horizontal distance? Horizontal distance is nothing but a distance of particular root, actually horizontal distance of a particular root from a particular node from the root. So let's define horizontal distance for the root is equal to 0. So what we'll do, if we move to the left of root, then we'll simply put the horizontal distance just -1 to its parents. So horizontal distance for 2 will be -1, and horizontal distance for 3 will be 1 because we are moving at right. So we'll move to left. Whenever we'll be moving to left, then we'll be subtracting 1, and if we move to right, then we'll be adding 1. So horizontal distance for 6 will be 2, and horizontal distance for 5 will be 0, and horizontal distance for 7 will be -1, and horizontal distance for 8 will be 1. Now just look at the intuition. We are going we are going level by level. So we firstly explore all the nodes of this level. So let's do that. In the first level only one node is present, so over here horizontal distance will be 0. Okay, now we'll move to the second level. Now the over here catch is, uh, whenever we encounter a node with a particular horizontal distance which is coming for the first time. So over here, if we are exploring this complete level and we are encountering the horizontal distance 0 for the first time in our traversal, so don't you think like it will be directly visible from the top if it is coming for the first time? So over here 0, horizontal distance 0 is coming for the first time for the node 1, so it will be directly visible from the top. Now let's move to the second level. In the second level we have 2 and 3. So for the 2, if we move to the 2, then the horizontal distance for the 2 will be just -1 to its root. So its root horizontal distance was 0, so its horizontal distance will be -1. So it is written over here. Now -1 horizontal distance is coming for the first time, so it will be our answer actually. So what it means, it means that it will be visible from the top. And then we'll move to the 3, and its horizontal distance is 1, and 1 is also coming for the first time, so our answer will be 3 also. So the what will be our answer? 1 will be our answer, 2 will be our answer, and 3 will be our answer. Now let's look at the next level, this level. In this level, firstly 5 is coming, and 5 is having horizontal distance 0. Now just observe that 0 has already came, means horizontal distance 0 is coming for the second time. So if it is coming for the second time, it simply means that it will it will come below some other node actually. So it is coming below the 1, so it will not be visible from the top. So we simply ignore this node. Now let's look at the other node, which is 6, and 6 is having horizontal distance 2. So it will be 2 is coming for the first time, so it will be visible directly from the root node. So 6 will be our answer also. Now look at the last level. In this level we have 7 and 8, and 7 is having the horizontal distance -1. -1 is coming for the second time, so it will not be visible. And we can also see that it is coming just below the 2, node 2, so it will not be visible. And talking about 8, and 8 is having horizontal distance 1, so 1 is also coming for the second time, so 1 will sorry 8 is also coming for the second time. Not 8 actually, 1 is 1 horizontal distance is coming for the second time, so it will not be visible. And we can also see that it is coming just below the 3, so it will not be visible from the top. So these are the nodes that will be visible from the top, and we have just to print these nodes for this particular problem. Okay, now we need to understand that how can we maintain this horizontal distance and answer also. So while traversing these things, we have to maintain horizontal distance, and we also have to maintain what can be the answer. Okay, so let's look at the approach, like what I'll do, how I'll do this problem. So for traversing in level order, I'll use a queue, simply queue. So there will be a queue. In the queue, I'll push two things. Queue will be a pair type of queue. So it will be a pair type of queue. In this queue, what will be the values? A particular value will be a node, and it will be a integer value, which will be a horizontal distance for particular node. So there will be a node. Oh, I'm so sorry for this. There will be a node, and there will be a value which will be an integer value, and it represent horizontal distance for the particular node. So we will having the track of horizontal distance for the particular node. Okay, now what we'll do, whenever a node will come, we'll simply push this node with horizontal distance in the queue. So let's run for this particular tree. Actually, let's run for this particular tree. So let's assume we have a queue over here. Now we will run our technique in this problem. So over here we'll put queue, we'll put 1 with its horizontal distance, which is 0, in queue. So 1 0 will be present. Okay, now uh, now we'll now we will pop this horizontal this node, and while popping we just need to check if zero horizontal distance is already came or not. So for that I just need to take a map, just need to keep track of horizontal distance, and also you can observe that a particular horizontal distance is coming for the one time only. So what we can do, in the map we can create a key with horizontal distance and can set the value with the nodes value. So over here what we can do, one has came. So what we can do, we can create a map with the key, we can insert a value with the key 1, and it will be having value 1. So in the map 0 has came, and 1 will be its value. So we'll pop this. Now while popping this, we'll push all the children of these nodes in this node uh, in the queue. So what will be the next node? The next node will be 2. So because left is 2, so we'll push 2, and its horizontal distance will be roots horizontal distance minus 1. So 0 minus 1, that is minus 1. So we'll push minus 2 minus 1, and the next node will be 3, and its root will be its horizontal distance will be roots horizontal distance plus 1, because it is the right child. So whenever we go to the left, we'll just simply do minus 1, and while go to the right we simply do plus 1. So its horizontal distance will be 1. So total overall these are the nodes for now, for this particular level, for the second, for the level 1 and for the level 2. Okay, now I'll pop 2 minus 1 from the queue, and it minus 1, I'll just check that minus 1 is coming for the first time, means I'll just check if minus 1 is already present in the map as a key. It is not present, so I'll just simply put the -1 in the map and also map the value of which is related to this, which is 2. Okay. Now I'll push all the children of 2 minus 1 in the queue. So there is no children, so we don't need to push anything in the queue. Now we have 3. Okay, so we simply pop 3 and its horizontal distance is 1, which we check in map if 1 is already present. No, it is not, so we add 1 with its value in map, which is 1 comma 3. And now we already pop. So now what we do, we we push all the children of 3 in the queue. So let me design the key. It is the extended part of this actually. So over here what I'll do, I'll put I'll go to the next level and put 5 in the queue. You already know level order traversal, I think. So if you'll be getting, like getting this approach actually, that what I am doing. So we'll be putting at 5 and 0. Why it will be 0? Because its parents node, which is 3, having horizontal distance 1. Now the 5 is left child of a 3. So over here what we'll do, we simply do -1. So 1 minus 1 will be 0. So 5 comma 0 will be inserted in the queue, and the next node will be 6 comma 2. We already had calculated, so you can see in the figure 6 comma 2. Why it will be 2? Because the horizontal distance for the 3 was 1 and 6 is the right child of 3, so it will be +1, so it will be 6 comma 2. Now we simply pop 5 comma 0. Okay, now look at in the map, 0 horizontal distance has already came, so it will not be our answer for sure, because it is coming for the second time. So it will for sure come below some particular node. So over here you can see 5 with horizontal distance 0 is coming below the 1, so it will not be our answer. Now move to the next node, 6 comma 2. And one thing also, now we cannot move without inserting child, so it is not coming for sure, but we'll insert its children in the queue just to maintain the level order traversal. Okay, so now we'll put 7 in the queue. So we'll put 7 horizontal distance, its horizontal distance will be -1. So we'll put 7 -1, and we'll also insert 8. So let me, okay, it is getting little messy, no problem. So now we'll put 8 with horizontal distance, 1. Okay, hope it will be visible to you. Okay, so over here we'll pop 6 2, and we just look at the map that 2 is coming for the first time, so we'll insert 2 in the map, and its associated value is 6. And we'll push all the children of 6 in the queue. There is no children for the 2, so we will not push anything. Now we'll pop 7 -1, and when the -1 is coming for the second time, we'll not push in the map. Then push all the children of the 7. There is no children, so don't need to push. And we'll pop 8 comma 1. Then 1 is coming for the second time, so it is not inserted in the map. So this is the final map. And for just printing from left to right, what we can do, we simply can sort this map uh, on the basis of key, and just run a loop in the map and print all these values. You'll get your answer. So let's code it out, the problem. Okay, So this is the function that we have given, and we have a root node. So what we'll do, we need a queue to make the um, level order traversal. So we'll take a queue, and queue will be of a pair type because we need a node, and also uh, we need a particular horizontal distance actually. So it will take a node star and uh, and actually integer value which will be horizontal distance. Okay, so there will be a queue, and we also need one map. uh, in the last I had shown, we need to sort this map. So what actually I am doing, I'm just taking the ordered map uh, for the just sake of sorting, like will not need to sort at the end, will not need to sort because the sorted map is already sorted. So we'll take a map in which it will be integer, okay? Integer, and okay. So these are the things that we have required, and now we simply put root node in the queue. So queue dot push, over here we are pushing the root node. So we have to make pair, root underscore pair, and we'll put root and its horizontal distance. So we have already defined that root's horizontal distance will be 0. So I'm putting 0 over here. Got it? Now I simply run a loop in this queue while queue dot empty is not equal to false. While q dot empty is not equal to false, what it means that while q is not empty, okay, while q dot empty, sorry, condition is on, but q dot empty is equal to false. What it means? It means that we have something in the queue. Queue is not empty actually. Okay. Now for this, I'll just pop the element of the queue. So queue dot front, I'm taking the front element. Let's suppose I'm taking in the temp, and temp will be of a pair type because queue having pair type value. So I'll define a temp over here. It will be of a pair type. So let me define pair and node star on my int. So it will be temp. Yeah, so q dot front temp, and I'll simply pop this node actually. So q dot pop, it will be popped from the top of q. Now over here, I'll maintain that map actually, which I was talking about. So over here, I simply check what is the value of horizontal distance for this current node, which is stored in the temp. Okay, so I'll check if temp dot second, if temp dot second is already present in the map. So what is the function for that? M dot find temp dot second is not equal to m dot end. What it means? It means if it is not present in the map, this key is not present in the map. So temp dot, what will be the temp dot second? Temp dot second will be the horizontal distance for this particular node. Okay. Now, if it is not present, then we simply put temp dot second as a key, and its value will be temp dot first, temp dot first, temp dot first data. Okay, because it is actually node, so we need to access the data for getting the value. Okay, okay, this thing is done. Now we simply check if m dot the current node, current nodes, if current nodes left is present, then we simply push this node in the queue. Queue dot push make underscore pair underscore pair sorry underscore pair. We have simply push this particular node with horizontal distance calculated from the root. So its horizontal distance will be temp current node's horizontal distance, which is temp dot second minus 1, because it is a left tree of a binary tree. It is a left node of a particular node. So I simply copy and paste, and I'll simply quickly do it for the right child. So over here right child, and over here I'll push the right child, but over here the situation will be different. In the left child, I was doing -1, so over here I will do +1. So now it's done. Now I just need to get the answer. So I'll define over here there is an answer vector. So I'll define a vector answer answer, and I'll push all the nodes in the answer. So I'll simply run a loop on this map and simply get all the values. So over here we don't need to sort, because it is an ordered map and it is already sorted. So we just need to get the values. So I'll do answer dot append. What actually required thing. So over here we also not need to maintain the answer. We just need to print the answer. So we don't need this actually. So we'll comment out this, and over here we don't need to append anything. We simply can print that particular node. So we simply can print I dot we simply can print I dot second. Why I dot second? Because we have to print nodes value, not the horizontal distance. So we'll be printing I dot second. Okay, that's all. Let's run the program. Any problem? You resolve it. Okay, some problem is coming. Q dot off. I just missed semicolon over here. No problem. Let's run it. Okay, some other problem is coming. M dot first left. It is saying something. There is no member of first. Okay, okay. So it is saying M dot first. I have written M dot first. It will not be M dot first. It will be temp dot first, and it also will be temp dot first. It will be temp dot first, because we already had temp. It will be temp dot first. So let's run the program. If any problems came, we will resolve it. Okay, it is saying no response on the std out. Okay, so had to give some space, and m is not coming, so let's resolve. Nothing is inserted in m dot find, m dot second, m dot end, everything is perfect. So what is the problem? Why it is not coming? They're saying no response on the std out and something is printed. So let's run the code again. Okay, let's see no response on the std out. Okay, now let's debug it out. Why it is not working? Okay, in the first we had post post make underscore root comma 0, and map we already had map and q. Then we only need a vector false to the top and not point and not second present. Okay, okay, over here condition was wrong. So condition is m dot find m dot second is equal to m dot end. What it means? It means there is no child sorry, there is no key available with m dot second. So this will be a condition. Let's run the code. Yeah. Okay. Over here you can see that it is passed the sample case. Now let's submit the code. Now it is running in some test cases. It is taking time. Yeah, you can see the success message. All the test cases passed successfully. Okay, so this was the approach to solve this problem, and let's discuss the time and space complexity for this problem. So over here we are using. Let's discuss a space complexity. Okay, what will be the space complexity? So over here we have used a queue, and we already have used map. Okay, and this is a pair type. So I'm just this is a simple variable of pair type. So the space complexity for this will be, it will be a big of n, and because there are two things we are storing, so we can consider that it will be only big of n because there are n nodes. And for map this will also be big of n because we, like at first case all the nodes can come in the map, so it will be big of n, and this will also be big of n. So the total complexity will be big of n actually. Total will be big of 2n, but we never consider constant term while calculating the space complexity. So the overall complexity will be big of n. Okay, space complexity will be big of n. Now let me write over here. Space complexity will be big of, sorry, big of n. Now let's calculate time complexity. Time complexity will be okay. Over here we are simply running a loop on a queue. Okay, so we are taking element one by one, and putting in the queue. So at max, what will be the time complexity? At max, we are touching a particular node for the ones only. So at max, we will touch all the, at max, what will be the time complexity? The time complexity will be n because we are touching all the nodes for the ones. Okay, and over here we are simply just printing the value which is stored in the map. So over here this the worst case time complexity over here can be big of n. So for this loop it will be big of n, and for this loop also it will be big of n for the, in the worst case. So overall complexity will be big of n. So that's all. Thank you for watching.